Our next panel is Moonshot, Chandrayaan 2 and India's new space Odyssey. It's a very unique panel featuring one of the more senior delegates of BGM, Dr. Surendra Pal from 66 batch, who spent over 4 decades in ISRO, and Awais Ahmed, who graduated in 2018. And he has done something unthinkable until a few years back, building a space tech startup. And the panel is sponsored by Ultratech and is moderated by Dr. Vijay Chandru, a distinguished alumnus and a pioneer in India who started the trend of academicians and scientists turning into entrepreneurs. I welcome all of you to the stage. And Dr. Chandru, please take over.
Wonderful to be here back on this campus. I think I was here in the early days when the first TEDx events were held in this auditorium, and it was amazing to have such a large auditorium and audience in here, and today is no less. So I think now we'll switch to a slightly different track in the sense that, and I think we should change the title a little bit. It's actually Moonshots, and in the plural, and Space Odysseys that we're embarking on. But I think I'd like to, I think it was Pritish who, in the venture capital group, that actually brought up this idea that, it's sort of deep research from academic centers and so on, which lays the framework and which then leads to extraordinary innovations. And in many ways, the public sector has actually played important roles while we don't always acknowledge and notice that. For example, the Indian drugs and pharmaceuticals and biotechnology sectors could not have taken off without the investment in IDPL and various research centers that were set up. The same is probably true of information technology. Again, people don't realize this, but in the late 60s, when Vittal headed the Department of Electronics and actually noted that India had a special talent for software and that we should actually tailor a lot of the investment into giving access to computers, connectivity, and so forth. That was an excellent sort of strategic approach. And the beauty of it was they took it to a certain stage and then let the entrepreneurs take over. And I think that was brilliant. And I think space research certainly, again, has that flavor that where we need a long-standing investment from the public institutions to take that forward. I think we have an extraordinary opportunity here from experience and extraordinary entrepreneurial sort of energy that are combined here on the panel. I think maybe first we do a quick round of introductions about our Pilani sort of coordinates. I did electrical engineering from 1970 to 75. I
did BSc in 66, MSc Physics in 68, MSc Tech in 1970, and I belong to an era where Pilani, BITS, first started with Birla Engineering College, Birla Science College, Arts College, then BITS, and it was a Gurukul. I had a uniform to put on. I think some of the persons may be there. And we used to have Ram Laddu given by whenever G.D. Birla used to come. So Birla ji used to give us Ram Laddu.
Yeah, I joined BITS in 2015 for a dual degree pursuing masters in math and bachelor's in mechanical, but then I completed my masters and dropped my mechanical to concentrate full time on Pixel, so graduated last year in 2018.
Right. We should find out. Aru, are we going to be able to project the PowerPoints. Uh, well, just give it a minute. We'll start in a minute. I just wanted to give a few introductory remarks. I think first of all, we have to realize that Dr. Surendra Pal has been, I guess, with ISRO since 1971, sir? Is that 71? He was initially at Tata Institute of Fundamental Research, and then, got involved in ISRO very early on. He's been involved in designing many of the antennae, and including for Chandrayaan 1, I think. And then I met him recently when he was the Vice Chancellor of the Defense Institute for Advanced Technologies in Pune, and then he has come back now to ISRO as a distinguished scientist to continue to mentor the Satellite Navigation Center there. I think we'll ask him to give us a little bit of the history of the whole sort of space movement in India. But just a few words before he gets started is that, of course, we are all aware of the Chandrayaan missions, and I think the session is actually advertising that. And as you know, we have also now got an announcement that Chandrayaan 3 will happen in 2021, or maybe towards the end of this year if they're lucky. But 21 is more likely. And of course, Gaganyaan, which is also our first manned space flights, December 2020, which will be a test flight without a crew, and then in 2021 with a crew of 3 astronauts aboard. So some interesting things yet to follow, but of course I think what we thought was we'd structure this as past, present, and future, of course. When we talk about the past, we always talk about celebration. It's a legacy that we're celebrating. And so we'd like, of course, Dr. Pal to give us a view of that. When we talk about the present, it's an assessment of where are some of the challenges, what are some of the opportunities. And as a young entrepreneur in this space, in space technologies, I think we'd be delighted to hear from Awais about where they saw the challenges and the opportunities and the way they took it. And then we'll wrap up with a discussion about the future, and it's sort of the 2030 view of where we think space missions and space research and space technologies will be in a 10-year sort of horizon. So with that, let me request Dr. Pal to get it started. I think he has a little presentation that he'd like to play.
If it can start before that.
Maybe you can use the
Thanks,
podium.
Professor Chandru.
Right, sure.
I also wish to thank late Professor Sarabhai for keeping me in India, because there was a tradition at that time that now also it's there, that go to USA, and majority of my classmates and batchmates are in USA. So I started the program with the satellite. Now let me tell you one thing. We started the satellite program when nothing was there in the country. Even fiberglass was not made in 1970. I wanted aluminum for my communication system boxes. I was asked to work on AM and FM, and aluminum was not there, so we had to approach Indalco, some aluminum alloy, and Indalco said, minimum 7 tons of aluminum we can give you. I asked my boss, Professor Yuva Rao, who was my divisional head, that, sir, I need 5 to 10 kg, what will I do? He said, buy it. The finance officer will object it. You tell him that we want to make fence out of it. And all 7 tons were used. So I'm going to talk to you about, quickly, because, this is Professor Sarabhai's vision. There are some who questions the relevance of space activities in developing nations. To us, there is no ambiguity of purpose. We are convinced that if we are to play a meaningful role in the Committee of Nations, we should be second to none in the applications of advanced technology to the real problem of man and society. And we still follow it. See, Professor Sarabhai in 1967 and 68 told NASA that when they were building the ATS-6, that India will be the laboratory for using satellite for educations. And mind it, we were not making even radio in the country, but we made televisions. ECIL made the television sets, the antennas made, and at least 6 states that experiment was conducted. India was the first country. It was called site experiment, where satellite was used for education purposes. If you see, there is a church building, famous church. The Indian space program started from there, and the first rocket was launched. It was given by NASA, Nakia Paiji, and Japan. And the first rocket which India made was RS-125. It was 125 is 125 mm of the diameter. And today we make GSLV, which is almost 3.5 meters in diameter, which can carry at least 8 to 10 kg of 10 tons of weight. So when I was talking about Aryabhat, because I started from Aryabhat to Chandrayaan and still I am associated with it, we started Aryabhat where the structure weight of the satellite was 26% of 463 kg of satellite. It was launched by Russians. And today we make tons of satellites whose structure weight is 2.6%. So we have advanced. India has done remarkably well. We have got our own GPS global positioning system called Navik. We are going to send the man into the space. And we were the first country in the world which in first attempt went around the Mars orbiter, Mars, and also in our Chandrayaan 1, first time we went around the moon. I worked with Dr. Kalam. Dr. Kalam said, why not we land something there? So we had a moon impact probe. It landed there. I won't say it landed because the speed was, or velocity was 6,000 kilometers per hour. So it simply crashed on it. So quickly we see, we started from there. Thumba, Dr. Sarabhai started from Thumba because the magnetic equator passes from there. It was to be used only for experimental purposes. Today we have got the Indian space program, which we have got PSLV, GSLV, reusable vehicles, modulars, Earth observations, communications, navigation, space science, planetary missions, and capacity building and space application. Our main purpose is for applications. Professor Sarabhai wanted to use space for for Indian masses, for the farmers, and we have gone. He didn't want to go to the interplanetary mission, but we have fulfilled all his dreams, and we are going to interplanetary mission also, Mars, Moon, etc. So, this is a slightly old slides. We launched more than 100 our own spacecraft. Foreign spacecrafts are more than 350. And we have PSLV has made almost 48 slides, 11 GSLV, and Mark III is going to take up the Gaganyaan in 2020 or 21. And if you see the thing, we started with a simple Aryabhat with AM/FM modulation, with the solar panels supplied by Russians. And some persons feel we got the technology. I was associated from Aryabhat. Russians never gave us the technology. They only gave us the launcher, and that was a modified missile. So we have got launch vehicle program. The biggest or heaviest is GSLV. We caught it FAT. Then we also have got satellite program, communication, navigation, and remote sensing. Mind it, India is the only administration in the world which has got the highest number of remote sensing satellites. And except our friendly country, Pakistan, everybody else in the world uses, including China. Then we have got Gaganyaan, we have got reusable vehicles. And I told you, we have got our own navigation system, Navik, which is the Prime Minister, it's a navigation Indian constellation. Prime Minister has named it Navik for the boat persons. I'm just saying. So space technology applications are quite a bit, we have done it, and mostly for sustainable development. So you see the TV everywhere. There was a time in 70s when you can't come in direct contact with the satellite, but now you could, with this TV, you are directly in contact with the satellite. We have got an international cooperation with almost everybody except our friendly neighborhood Pakistan. We have made a satellite called SARC satellite, which is used by SARC countries except Pakistan. We also sent a satellite in the space called Space Capsule Recovery Experiment in January 2007 and brought it back successfully. I think in the first attempt. So the same experience will be used for Gaganyaan. Then this is the Indian mission to Moon, Chandrayaan 1. In first attempt, we went into the... But see, making a satellite is not difficult for us. Launching is not difficult. But managing the mission is very difficult. And when the satellite, when the moon mission, when it comes, it should come into the capture orbit. And we have got only 2 hours of time. So it has got 3 options. It can become elliptical orbit of the moon, it can crash on the moon, or it can become hyperboloid, paraboloid. So we cannot afford the 2. We have to go into the elliptical motion. So this is the way how we try to do it, mission to moon. So this is when impact probe was put. You can see Dr. Madhavan Nair and Dr. Kalam, who was there at that time. And exactly on 8:30 p.m. Friday, Chandrayaan 1's moon impact probe landed. And this moon, we had a mass spectrograph on that one. That moon impact probe found out that there was water traces on the moon, and it was Chandrayaan 1 which found out that water was there on the moon. Otherwise, nobody was thinking. This is the Mars orbiter, almost the same thing. We were the first to enter into the Mars orbit without any failure in first attempt itself. And well, when we launched the Aryabhat, in 2 rupee note, there was some of you recall, Aryabhat photograph was there. On 2000 rupee note, the Mars orbiter is there. That's what the government of India gives us. So we have got a Chandrayaan 2, which had, all of you know, the orbiter is still working. And we had some problem. So that, there was a complex interplay of propulsion, sensors, and the logics. We have found out the reason, and the same thing will be done in Chandrayaan 3. Propulsion module will go, the lander will be there, the rover will be there, and everything will be there. So I'm just skipping because, see, it's almost total weight is more than 7 tons, which the GSLV took it. And everything has been made in India, in Bangalore. Of course, when I started my career, industries were not there. Only machining we could do. Now industries can do many things. And this is the various operations in the clean room. We have got the best facilities. We were under sanctions in 90s. And that, I think that was the golden period when we developed a lot of technology. And US put the maximum sanction. We have launched more than 120 satellites of USA.
So I think...
well, this is some of the views from Chandrayaan. This is a human space flight mission, which will be launched in most probably 2021. Already the efforts are going on. The module, etc., everything has been made, and astronauts are getting trained in Russia. We have got a collaboration with Russia as well as with France. So sky is not the limit. Nothing is impossible with hard work. Nothing is possible without hard work. We are better among the best. And let me tell you one thing. India is an incredible country. Let me also tell that we work with shoestring budget. You know what is the overtime for a technical assistant or an engineer if he works after beyond 5 o'clock? 1 dosa and 1 filter copy. Thank you very much.
So I think we should give a standing ovation to the incredibly pioneering scientists and engineers of the country who have created this amazing space program. Thank you, sir. Now, I would like to call on an alumnus who I guess finished about 7 months ago, right? So it's amazing. We have probably one of the most senior, alumnus here on stage, and probably one of the youngest. And the amazing thing about Abhay Ahmed and the Pixel venture that they have put together is that they started something so ambitious even while they were on campus, right? And so it's a remarkable story, and I will let Abhay tell you more about it.
Thank you, Professor. So yeah, as he said, Pixel came into being when I and my co-founder Kshitij, we were moving into the final year at BITS on campus. And we had some sort of a brush with dealing with complicated engineering structures because we were part of the Hyperloop India team as well. The SpaceX has this annual competition where they have a 1 mile long vacuum tube, and they ask universities around the world to build a vehicle that could travel at the speed of sound inside that tube. 2,500 universities had applied in 2017, and there was just one Indian university chosen, and that was BITS Pilani. And we didn't have the infrastructure to actually build that vehicle in Pilani, so we had to move down to Bangalore, but we managed to manufacture it in 3 months, take it to the SpaceX headquarters, present it to Elon Musk. So that was sort of the first brush that being in BITS gave us the opportunity to. And once that was done, we were looking for a new challenge, and we came across another competition called the IBM Watson AI X Prize. Now, that competition stated you needed to use artificial intelligence to tackle some problems that humanity as a whole was having, and we narrowed down on using it on satellite imagery, because for us, logically, that seemed like a very good data set to tackle things large scale. For example, illegal mining in Rajasthan, the state where we were studying, was rampant. Pest infestations were ravaging the crops around the country that year, and in fact every year. Delhi and Gurgaon being 3 to 4 hours away, they were some of the most polluted cities in the world. Where were those emissions coming from? How do you see, how do you tackle and keep a check on that? And satellite imagery was the data set that could enable us to do that. But that's when we realized that, if we look at satellite imagery available to us today from NASA, ESA, or other international companies, it's either very, very expensive, it's not frequent enough, and more importantly, it was not rich enough in information to even see certain problems. If you were trying to figure out which mineral was being illegally mined, that was not possible. If you were trying to figure out what specific strain of pest infestation, that was not possible. So essentially, the opportunity we saw was there was a possibility to build something that was much better than anyone anywhere in the world had done, and do it out of India, because as Dr. Pal said, ISRO has had the heritage of launching multiple Earth observation satellites up there. So we have the infrastructure in the country, we have the expertise in the country, and we have the talent in the country to be able to do that. Those two sort of converged, and we decided, what we will do is we will build our own constellation of satellites from India. We will launch it so that we can provide global coverage to any part of the world every day, and be able to see the changes that are happening and help make Earth more sustainable. So I think that was the story. Since then, we have completed the manufacturing of our first satellite, which is completely built here in India, in Chennai, in fact, and it's booked for a launch in June this year. So when we launch it in June, it will be the first private satellite of its kind in the world, and India's first private Earth imaging satellite launched. I think that's the story of...
Well, I think the way I sort of understood what you were up to when we met last week was that while ISRO has been building satellites and technology for India and maybe for SARC, I think what you're going after is a more of a global model. So in fact, as was discussed during the venture session, what is global about your company? How are you actually set up to maybe address a much larger market?
So if you see the way ISRO was set up, it was a necessity back then because you needed space technology for communication, for Earth observation here, and that was the philosophy there. So the satellites they send up is concentrating on the Indian geography, and that's what it's been. But when we looked at the United States, there were companies like SpaceX or Lockheed or Boeing that were doing something globally. If we looked at Europe, there was Airbus that was doing it. But then if you look at India, there was no company or entity like that that could go toe-to-toe with these stalwarts and stake a similar claim, and that was where Pixel came from. And as mentioned in the venture panel, the landscape in India is changing where US companies came to India for outsourcing. Rather now companies are building in India for the world, and that's where we came.
Yeah, so that's outstanding. And I think, do you see any major challenges, thank you. I thought we had 10 minutes, but that's okay. Right. We'll wrap up. Have you run into anything that looks like a challenge in terms of regulatory or other aspects?
I think that was also touched in the venture panel. The fact that some areas like pharmacy or space need to have institutional backing from the government and from institutions in the country. And in that sense, even though the landscape is opening up where ISRO is trying to privatize it, it's not been fast enough. Right. Because when we started, there was a lot of confusion on what licenses to get, how to go about it. In fact, even today, if you are booking a launch on the PSLV as an Indian company, there's an extra 18% GST we have to pay compared to a foreign company. So it's definitely opening up, but if you look at how China did, in the last 2 years, they said US is getting ahead of us in terms of space tech. We're going to revamp how the space policy in our country looks. That's something that needs to be done faster. So it's definitely moving in the right direction, and our conversations with ISRO and the Department of Space have been nothing but positive. But in terms of moving at the pace that you need to move to have global innovation, it can be done much faster.
I work closely with the drone group at the Indian Institute of Science, and of course, this new digital sky policy has come up. And is there something like that is needed for satellites? Because there's really a lot of
first is ISRO is developing. No, first I'd want to make one statement, sure, with your permission. See, India is not a developing country. India is a developed country. I had an association with ISRO, with atomic energy, and with defense. And of course, with the medical science, Professor Chandru is the better spokesman. So India is a developed country. For launching the small satellites, ISRO is developing a small satellite launch vehicle. And that will be available to persons like Airways. Okay. We paid money, we encouraged the students, a lot of student satellites were launched by ISRO, and we paid money, and we also gave the equipments and guidance to them. First was the Anna University satellite, which we did not go in well in time, but there was a student set which went by the, there was a consortium of a lot of colleges where students made it. So ISRO encourages, as far as there is a sky policy of the government of India is there. And mostly it's covered by what you are going to do it, what's your transmission frequencies, what's your purpose, etc., which are needed for the security agencies, etc. The last thing which I want to say is the persons like Airways, there are a couple of companies that are coming up. ISRO itself needs a lot of small satellites. Our first IRS-1A satellite, remote sensing satellite, was 827 kg. What it achieved in 827 kg can be achieved in 47 kg. So that's the technological advancement, and that's available in the country also. Our industries have gone up. So not only because IT, we are quite advanced in other sectors also. And ISRO encourages persons to make satellites. And a lot of ISRO retired persons are there who are guiding them. A lot of companies have come up. His is one company. There is another company which is in Ahmedabad. They propose to make 100 satellites per year. And a lot of space application center persons have come. So it's open to them. And there is a proverb, it's not a rocket science. Let me tell you, rocket science is not a difficult science. Because we did not study, we did not have book also. When I started the career, there was only one book available, 1968 Bell Telephone Journal in whole of Vikram Sarabhai Space Center, and we used to rotate it by year, go in the night in Trivandrum, I was there, take a cycle or go walk, take 11 to 12 o'clock I'll study, because that was the only book, there was no Xeroxing. So if he could do from there, definitely persons like him will do much better. I see a bright future in space.
Good. I mean, we used to share textbooks and bits, right? So that was because there weren't enough copies. So that, we've all lived through those cultures. I think we'll wrap up now with, I'm going to give 1 minute each for you to tell us what is the big vision? Where do you think we could be in 2030?
So I think Vikram Sarabhai obviously was the pioneer who helped space develop here. And as he said, in space tech and definitely other areas of technology, we're not developing but are quite developed. Going ahead, what Vikram Sarabhai said was we need to stop looking at other countries and replicating that, but rather leapfrog and do what is cutting edge. So in terms of that, the Gaganyaan mission that's coming up, where ISRO will send humans up to space to do flight experiments. And then with Chandrayaan and with eventually there's going to be Mars landers. So in the next 10 years, there's definitely going to be, with NASA and ESA pushing it, initial settlements on the Moon and the Mars. And the potential for the lower Earth orbit by putting satellites and having them turn into useful applications on ground is immense. So the next 10 years, there's going to be a lot of privatization of this, where institutes like ISRO will be able to, with the budget that they get, concentrate on the more cutting edge research, and the private industries can take that up and faster and at lower cost provide the benefits to mankind. So that's what the next thing is.
So great entrepreneurial sort of opportunities. Dr.
Yeah, I find that there is a very bright future for the country as well as for the space technology in India. See, defense needs space technology, satellites. Agriculture needs satellites. For fast communication, we need satellites. For emergency purposes, we need satellites. So a lot of private industries have to come up for that purpose. And ISRO with small satellite launch vehicles, which will be also launched by private companies. Okay. So, and private companies will manage it. We are training them for that purpose. So I see a very bright future for the space technology in the country. And I mean, in ISRO, we don't compete with China or with anybody else. We always first see our purpose, that we should meet our requirements, then go beyond them. Thank you.
Thank you. And I would like to thank both panelists for sticking to time and getting us back on the clock. So, and I think, this has been such an important sort of theme and that we've been able to discuss here. Thank you all very much, and Jai Hind.
Thank you, Dr. Pal, Dr. Chandru, and Awais for sharing such phenomenal information about space technology and Chandrayaan mission. I think in an era where space technology is picking up exponentially fast, these are all exciting info for all of us too.